Assalamu alaikum student. Welcome to daily physics lecture session. Today's lecture is 5. In the previous 4 lectures, each lectures were more than 20 minutes. And a lot of students among you are telling me that, knocking me in via comment or phone, that why not I just keep my lectures within 10 to 15 minutes. So that will be easier for you to keep maintain more concentration. So from today, each lectures will be maximum. So here, as we are discussing about the circuit problems, in lecture 5 we will also continue the circuit problem section. So today we will discuss about an interesting topic, a tricky one but interesting, how to solve a parallel circuit in parallel circuit section. We'll discuss about how to get the voltage difference in a resistance which is inside of a parallel group. We'll discuss about this thing. So let's start the lecture 5. In today's lecture, we'll discuss about VP divide law. Okay, VP divide law. So already we know what is VP. Okay, so VP is the voltage difference between two sides of a parallel group. We already know it. So here I have given you a circuit. This circuit contains a parallel group where 1, 2, 3, these 3 resistors are in series in one line, and here we have another resistance in the other line. These 2 lines are part of a parallel group. Okay, and that group started from here and that group started from here and ended at here. So this is a parallel group, and we do know that the voltage in between this parallel group is VP. So now question is, if they ask us what will be the voltage through resistance R1. So what is the starting point of R1? Here, and the ending point of R1 here. So the voltage used by R1, if the question asks us voltage used by R1 or voltage difference between two sides of R1, this will be VP. And how do we get VP? By this equation. But what if the question says anything about voltage used by R3, that means this resistance, or R2, that means this resistance, or R1, that means this resistance, or R4, that means this resistance. Then what will we do? Obviously, the starting and ending point of R3 is not these 2, rather than these 2. So obviously this point and this point are not same, and this point and this point are not same. So voltage difference through resistance R3 or voltage used by R3 is not VP. Okay, then how do we get VP? So here comes VP divide law. So tell me, what is starting? So forget about the bottom group. Let's deal with the top group. So here you can see a line. This line starts here and ended here. So in this line there are 3 resistors, R1, R2 and R2. So equivalent will be R1 plus R2 plus R3. Let me tell you, the equivalent resistance of this line will be R1 plus R2 plus R3. And the starting point, the voltage in between the starting and ending point is VP. So as they are using some voltage being used by R2, some voltage is being used by R3, some voltage is being used by R4, and if they are V2, V3 and V4, so these voltages are being divided from Vp, because in between these 2 points the voltage is Vp, so V2, V3 and V4 all are coming from Vp. So here to get V2 we have to divide Vp, because V2 is not part of E, total EMF, rather than it's a part of Vp. So how do we get Vp divide law? Okay. So we want to get the voltage is by R3, and that's V3. Again, as it's not a E divide law rather than Vp divide law, so we will put Vp here, and at the bottom we'll write the total resistance of this line, and that is R2 plus R3 plus R4. And now for which resistance we are about to get the voltage? V3, that means the voltage difference through resistance R3, or voltage used by R3. So we have to write here R3. If we want to get the voltage used by R4, then it will be V4 R4. If you want to get voltage used by if you want to get voltage used by R2, then it should be V2 and R2. I hope you get it. Okay, so this was the Vp divide law, that is how to get the voltage of a point which is not in the voltage through a resistance which is not in the main line, rather than now you can understand how to get the voltage used by resistance which is not at the main line but at a line which is a part of a parallel group, and by using Vp divide law. So let's discuss a problem. Here we have a circuit. Here R1 is in the main line. We have a parallel group. Here 2 lines are in the parallel group. At the top line we have R3 and R4. These 2 are in series. At the bottom line we have R2, only one resistance. So here this is a mainly series circuit. So if for this circuit the question asks as these: number 1, calculate the voltage used by R1. Then how we will calculate? Let me tell you, at first you have to see where is your resistance. Here our resistance is R1. So where is R1? R1 is in the main line. Look, this line comes from the cell. So R1 is the main line. So here the voltage used by R1 will be divided from E itself. Okay? So if you use the voltage divide law, the voltage used by R1, V1, we will divide E. At the bottom, R out plus R. At the top, the voltage used by R1, V1. So at the top it will be R1. Now, if the question says that the voltage used by R2, then first step, where is R2? R2 is a part of a parallel group. So we know for parallel group, we have to get Vp. So where is Vp here? Vp is the voltage difference in between these 2 points, the parallel group. So here, the starting point of the R2 starts from here, and ending point of the R2 ends at here. So in between these 2, we have a voltage difference Vp. So voltage used by R2 or voltage difference through R2 is nothing but Vp, okay, as a part of a parallel line. So how do we get Vp? We already know R plus R into E. So for Vp, we have to put here Rp. That's the voltage used by R2. But what if the question says about calculate the voltage used by R3, that means this one, or R4, that means this one, then what we will do? So let's figure out why is R3. R3 is not a part of the main line, so it will not be E divide law. So R3 is a part of a parallel line, and here we know for parallel group we use Vp. So here the starting point of R3 and the starting point of Vp, though they are same, but the ending point of R3 and Vp are not same. So that's why unlike R2, the voltage used by R3 will not be Vp, as their starting and ending points are not same. So how do we get it? We know the starting point of Vp is here, the ending point of Vp is here. In between these 2 points, at the top line, we have 2 resistors. So Vp will be divided into these 2, into R3 and R4. So to get the voltage used by R3, we have to divide Vp. We have to divide Vp. How? So the voltage used by R3 is V3. So we have to go for Vp divide, right? So here it will be Vp. At the bottom, the total resistance within that line, because we are about to divide Vp, so we have to get the total resistance inside Vp. And in this line, the resistance is R3 plus R4. So for V3, we have to write here R3, and for voltage used by R4, which means V4, we have to write here R4. So now I hope you get why we have to use the E divide law and why we have to use the Vp divide law to get the voltage. So in the next class we will discuss about a very interesting circuit which is which looks like a series circuit but actually a parallel circuit. I have already given you the example, but a lot of students are not able to solve it. So we'll discuss about that problem. Very interesting, and please don't miss it. And share this lecture with your friends and complete HWs. Okay? Thank you. Allah Hafiz.